made a comment on one of my videos. He said, can you make a series on the tabs in EV3 and what you do with each block? And so today is my fourth installment of the series, the red tab or the data operations tab. The first block along is the variable block. What this block lets you do is it lets you set a variable name. So for this instance, I have speed that I already made. And I can write to it here at the beginning of the program. Let's say I wanted to set the speed to 20. Now right now, that does absolutely nothing. But if I was to read from here, no matter how far away, as long as I'm in the same program or in a different MyBlock in the same program, so as long as I haven't left the program and gone back to the menu of like the program select menu, I can write here and read somewhere else. And you can do cool things with that. Switch blocks that change values of stuff for later on, flags, that kind of thing. You can write text, numeric, logic, numeric array, logic array. I'll touch more on arrays in a bit. And you can read the exact same thing. The next block is the constant block. This block, instead of the variable where you change in one spot and you read in another, what the constant block does is it's constant. It doesn't change. So you set the value up here. Let's say, if we were going to go with what we had before, 20, and this will always read 20. There's never a time when this will not read 20. The choices for this one are text, numeric, logic, numeric array, and logic array. Same thing as the variable. I'll again touch on arrays in the next block. The next block is the array options block. So this block is pretty cool. So what arrays are is they're lists of numbers. So this is an array. 0, 1, 2, 3. So what we do is to be able to find out what number. So we have this array. It's 0, 1, 2, 3. We can find what is at each position by counting. So this first one, instead of being the first position, it's the 0th position. So 0 is at the 0th position in this array. 1 is at the first position. 2 is at the second position. 3 is at the third position. So kind of weird, but you don't want to waste a number. So you start with 0. What this array options block lets you do is it lets you do stuff with that list of numbers. So the default is read at index numeric. So you give it the array either by data wire, that's what this symbol means, or by just typing it in here. Oh, whoops, I removed 2. Can I drag it back? No, that's annoying. That becomes 2, and that becomes 3, right? And then we can say, at what index do we want to read? So we can set the index either by typing or by wire, and we can read from that. Let's say at the 4th one, well, that's out of range, so it'll give us an error. But at the 3rd index, if we did it right, it should read 3, because 0, 1, 2, 3. Even though counting, that seems like that's the 4th index. That's how the indexing works. And then this data wire right here will be the value that's at the 3rd index in this array. So that's, if you're typing it in, that's not very useful. But if you're doing things like data wires, where you're wiring an array, and let's say you wanted to, depending on what you wired into here, it would choose a different one from this spot and do something different based on that. Like you could plug this into a switch, and then you could do something different based on it. So you can do some pretty cool things with it. The next one, I'm going to start at the top, is append. So you can append to numeric. And so what this lets you do is this lets you state what value you want to stick in, and it sticks it in at the end. So if I wanted to add 4, this would stick it at the end, which would be the 4th index, and it would add 4. And so then from then on, it would, instead of just being 0, 1, 2, 3, it would now be 0, 1, 2, 3, 4. So that would be what that array. The next one, I'm going to skip over the first one, is write at index, numeric or logic. And this lets you do pretty much the same thing, but you give it the starting array, you choose the index you want to write at, and you give it the value you want to write there. So let's say we wanted to, instead of at the 0th position, we wanted to say 4 instead of 0. Well, now at the index of 0, we're writing 4, and this is our array out that has converted the change we specified. The next one is length. So I clicked on length numeric. You give it the array, and it gives you how many items are in the array. So in this case, how long is it? 0, 1, 2, 3. So it's 3 long. So then you can do things like with the append block, every single time something happens, append to that thing, and then find the length. And if the length is greater than such and such, do such and such. Otherwise, do blah. Right? You can do some cool things with that. Now, I've only been clicking on numeric, but there's also the logic. So a logic array lets you choose. Lets you make a list of trues and falses, and this one's append. So I'm sticking at the end false, and this is the logic array out. I'm reading at the index of 0. This is my array in, so the 0th one is going to be false, and that gives me my logic out. My write at index logic, I have the index, I can choose true or false, gives me the array out. Length logic, same thing as length numeric. There's not a single difference, except the fact you have to put a numeric array in. Okay, the next block is logic operations. This lets you do is and, or, SOR, and NOT. So in and, if A and B are true, this will be true. If A is true and B is false, this will be false. If A is false and B is false, this will be false. So only if both of them are true will it be true. And or, only if, so if A and B are false, this will be false. If A is true and B is false, this will be true. If A is true and B is true, this will also be true. So as long as there's at least one true, OR will return true. Now that's not true of exclusive OR. Exclusive OR means if they're both false, this will be false. If one of them is true, this will be true. And if both of them are true, this will be false. And then NOT returns the opposite. So if this is true, this will be false. If this is false, this will be true. This lets you do cool things with multiple compare statements for ending a loop. So you could say, if my gyro angle is greater than 2, or I've gone so far, then end the loop. So you can do cool things like that. Next block along is the math block. So this has the choices add, which adds a plus b and gives you the result in the equals. Subtract, which subtracts a minus b and gives you the result here. It's not b minus a, it's a minus b. So if we have a being 2 and b being 1, it will give us 1, not negative 1. Divide is a divided by b. Again, this will give us 2, not 1/2. It's a divided by b. Multiply multiplies a times b, gives us the result equals. Absolute value gives you the absolute value. So negative 2 is 2. How some people say it is it takes off all the negative signs. So you can guarantee it is a positive number if you absolute value it. Square root gives you the square root of a number. So if I said 4, then it would give me 2. The next one is exponent. So I say 2 squared, and that gives me 4. Because this is a is the base, and n is the exponent. So the base raised to the exponent. Then the last one is advanced. Don't let the fact that it's called advanced scare you away. All it is it has 4 inputs, A, B, C, and D, and you can specify exactly what you want in here. So I could say A minus B times C, and parentheses are free, so use them whenever you can, divided by D, right? and that would be a perfectly logical thing. I could say a modulo, which is divide and give me the remainder. I could say, maybe I don't want to go into all of these, but I could say exponent, so a raised to b, which you can do other ways. I can say negate, which is basically just a negative sign. I can say a whole bunch of other, you can take the log, you can take the sine, the cosine, the tangent, the a sine, the a cosine, the a tangent, and the square root. So you can do everything you can do in the other ones and more. And so it just does whatever you specify in the equation, and it does it to these, and it gives you the result. So you can do some pretty cool things with the math block. The next block along, well, if that one goes away, the next block along is the round block. This is helpful if you have a float, like, let's say you have an ultrasonic sensor that is, or no, your wheel rotations. So you don't really care if you've gone an additional half a rotation. You only want to know how many actual rotations you've given. So round will round to the nearest. So 0.99 will round to 1. So 4.75 will round to 5. So that's one thing you can do. You can just round it to the nearest number. Then we can also say round up. So always round it up. So like round to nearest will either round up if it's above 0.5 or round down if it's below 0.5. Round up will always bring it to the highest one, which might be what you want. If in our real rotation counter, you will say, as soon as it crosses the 4 rotation threshold, just tell me it's 4 rotations. Then there's round down, which always rounds it down. And there's truncate, which means just cut it off. I don't really care whether it rounds up or down. I don't want it to affect my whole number. Just slice it off. And so you say how many decimals do you want. If I want one number decimal of 4.75, it'll just slice off the 5, and it'll give me 4.7. If I said 0, it would slice off everything after the decimal point and give me 4. And that's what the equal sign is. The next block is compare. So this lets you say equal to, not equal to, greater than or equal to, less than or equal to. So this lets you say if a, so this lets you, because it gives out a logic. So that is a true or false. So it's not actually doing an if, but to make it easier to understand, I'm going to, actually, you know what, I'll stick an if on the end just so it is actually doing the if. So if A is equal to B, do this. Or if A is not equal to B, do this. Or if A is greater than B, do this. Or if A is greater than or equal to B, do this. Or if A is less than B, do this. Or if A is less than or equal to B, do this. So that's pretty straightforward, but you can do pretty cool things because you can wire these so you can compare sensor values, you can compare results you got from math of censored things. Once it becomes a number, you can, with these red blocks, you can do anything you want to with it. You can do anything to it, and it has become yours, and you have conquered it. And you can compare it every which way. You can perform operations on it every which way. You can just do anything to it. The next block along is range. So what this does is this lets you test. So it returns a true or false. So it lets you say, if this test value, the one with the bubbling beaker, if mouse over text says test value, if this test value is within the lower bound and the upper bound, give me true for the inside. The outside is if 50 is not within 25 or 75, 25 to 75, give me true. So in this case, it would give us false. But if I said, it would give us true. So that's kind of cool, But you can do other stuff with compares and switches that says if it is like if you don't want it to be able to go outside, I might do a video on this. Comment below if you want it. But you can say if the test value is higher than the upper bound, give me the upper bound. And if it's lower than the lower bound, give me the lower bound. Otherwise, give me the test value. So while this is pretty cool, you can do cooler stuff. The next block is the text block. And this block makes me sad because there's a little window here that makes you think, oh, I can do a whole bunch of stuff with text. Click on it, and there's the one option. It seems to be like there can be more they can do with it, and they just haven't integrated it yet. So I'm hoping if there are any Mindstorms developers listening, for the next evolution or even just the next update, do more with text. Probably aren't, but if you're there, do more with text. But the text block is still pretty cool. What you can do is you can give it 3 different text things, and it will stick them all together. So if I was to say A is hi, and then B is space, and then C is, or no, B is a colon. So hi, semicolon, colon, hi, hello. Right, and then this text you could put on the screen with a display block, and you could say put hi colon hello, because it sticks that all together. It sticks A at the front, B next, C last. So it merges it all together, as per its name, merge, and it sticks it all out as one string or text in EV3. Now the final block is the random block. It's random. In FLL, there is not much use for this. However, it is cool to do stuff with because you can do random stuff with it. So you can choose random numeric, where you can set the lower bound and the upper bound. So this one would choose a random number between 1 and 10 and give you that in this data wire. Or logic, where you set the probability of true, in this case 50%, so it's a coin flip. If heads it's true, if tails it's false. Or you could weight it. You could say, let's make it more likely to be false. So now 75% of the time it's going to be false, and 25% of the time it's going to be true. Or you could weight it the other way. 75% of the time it's going to be true, 25% is going to be false. You could do interesting stuff with that. The really fun things to do with this are power and spin amount. If you want to make a random dance program for your robot, just like have it like go a random amount of distance, spin a random amount, go a random amount of distance, spin a random amount, add a random power. I've done that before. It's kind of amusing to watch because it'll be random and it won't do anything logical.